In this lesson, we're going to look at the Simple Network Messaging Protocol, or SNMP. SNMP is an application layer protocol that lets you monitor network devices. Many network management solutions use SNMP to monitor all network devices, such as routers, switches, and computers. The network administrator can manage network performance and identify problems before they become major issues. To get the most out of SNMP, we need to understand its components, communication methods, and versions. Today we're going to start by discussing versions. The first two versions of SNMP were okay, but they had some serious issues with security. Neither version used a real password. They used a community string instead. What's a community string? It's an unencrypted, clear text password that every agent used to authenticate on the manager. The default password was the same for every device, and many people never bothered changing it. Because these passwords were transmitted in clear text and had no encryption, they were incredibly easy to intercept. A malicious user could modify information on the device and cause some serious problems without even breaking a sweat. SNMP version 3 has addressed many of these issues, and it's much more secure. It encrypts all passwords and uses more secure authentication methods between the manager and the agents. In the rest of this video, when I refer to SNMP, I am talking about version 3.0. There are three components that make up an SNMP management system: the SNMP manager, the SNMP agent, and the management information base, or MIB. The SNMP manager is usually a separate computer or server that manages and monitors the network devices. This server runs the network management software that uses SNMP. The manager is responsible for polling or querying the agents and using the data from the responses to manage uptime and diagnose the devices. If any responses come back as abnormal, the manager alerts the network administrator that there's a problem. The SNMP agent is the software that resides on each managed device. The agent collects data and information on the local device, and it communicates with the manager to provide status updates. The final piece is the management information base, or MIB. Every agent has a set of parameters that defines what it needs to monitor and get data for. That set of parameters is the MIB. The SNMP manager uses these parameters to ask the agent to gather data. The agent will then collect the data and store it locally, as defined in the MIB. Just remember that the MIB isn't the actual information being gathered. It's the guidelines and parameters for the information being gathered. The way the MIB labels devices can be confusing for new admins. Instead of labeling devices by their name, it uses an object ID, or OID. The OID is a unique identifier that describes the specific characteristics of each network object. It's a very structured hierarchical layout. If you want to refer to a Cisco device on your network, its OID is 1.3.6.1.4.1.9. Using the OID allows SNMP to look network objects up quickly and efficiently. SNMP uses two main methods of communication, polling and traps. Their end results are the same, but they work differently. Polling is when the SNMP manager polls or queries the agents to see what's happening on each device. These requests are sent over port 161 using the definitions contained in the MIB. This method has the network administrator tell the SNMP manager to send a GET command to the agent, put together the requested information, and send it to the manager. The agent will only send back the information that's defined in the MIB. The second method is to configure traps. In this method, instead of the manager polling the agent sends alerts based on defined parameters. This communication occurs over port 162. For example, if the device's CPU usage goes above 25%, the agent might be configured to send an SNMP trap message to the SNMP manager and alert the network management system. This helps a network administrator be proactive instead of reactive and fix problems before they become catastrophic. There are two types of trap messages. The older method has the agent send the message, and that was it. The SNMP manager didn't acknowledge receipt of the message. Newer SNMP implementations use inform messages instead. The main difference is that the SNMP manager acknowledges the receipt of the message. Inform messages are only available in SNMP version 3. And that's all for this lesson. In this video, we looked at the Simple Network Messaging Protocol, or SNMP. We looked at the different versions and security issues that were present in the older versions. Then we looked at the three main components of an SNMP system, which are the SNMP Manager, Agent, and Management Information Base. Finally, we went over the two communication methods SNMP uses, polling and traps.